Hey y'all, we are going to combine some like terms. Top left, where it says combining like terms, like being underlined multiple times. Okay, so when adding or subtracting, that's what I'm calling combining terms, they must be alike. Must be alike. What do I mean by like? This is having the exact same variable with the exact same exponent. So when you're looking at problems that tell you to simplify or evaluate the expression, combine like terms, in the green, that's kind of what you need to ask yourself. This is how I do it. Same variable, same exponent. If my answer is yes, what I do is I combine the terms, meaning my numerical values, my numbers, my 4, my 7, my 5, my 9, whatever it may be, right? I'm going to look at those individual values and pay attention to the signs and perform that operation. And then I keep variable, keep exponent. That's why they have to be the exact same. If they're different, how do I know which one to keep, right? But if they are the exact same, I can keep variable and keep exponent. If I ask myself, same variable, same exponent, and my answer is no, then they cannot be combined. You would simply just rewrite them the way they're written, but you couldn't actually perform any math on it. Can I call you right back? Okay, love you, bye. It's like 6 o'clock in the morning. It was a phone call from my husband. Okay, so if they do not have the same variable, they do not have the same exponent, they cannot be combined. So on the right, I have some examples. In purple, I have 2x, 4x, negative 6x, and x. These are like terms because they have the same variable that has the same exponent. They all just have an x. It's okay that 2, 4, negative 6, and that 1 are not the same value. Whenever I'm talking about combining all of these terms, in order for them to be like, they have to actually have the same variable and the same exponent. That's the main thing that matters. Okay, so this is when adding and subtracting our variables. So in green, 12y, 7y, 9y, negative y. Those are all y. Don't let that negative y at the end confuse you. That's just saying that the coefficient, right, the number that's attached to my y is a negative 1. You just don't write 1 because you just don't write 1. Honestly, mathematically, writing 1, not writing 1, the answer is still the same. But I'd like to think that people who do math are inherently lazy. And if we don't have to write a number, then why write the number, right? Okay, so blue, 36a squared, 2a squared, 4a squared. They all have an a squared. Specifically, all of the variables have the exact same exponent, so those are like. Alike, like, it's same difference. Okay, red. It's kind of funny I wrote it in red because it stands out like stop, can't do anything here, okay? 2x cubed. Cubed is going to be the exponent of 3. So 2x cubed, 2x squared, and 2x. Do they have the same variable? Yes. Do they all have the same exponent? No. Cannot be combined. If you saw those in a problem, you can't actually perform any operation at all. They just are what they are. They stay what they are. They're not going to change because they can't be combined with anything. So let's do an example. Let's start with problem 1. If I have 4c minus an 8c, or 4c negative 8c, 4c subtract 8c, those are all saying the exact same thing, okay? So what I do is I look and I'm like, okay, same variable, yeah. Same exponent, yeah. Okay, I answered yes to both questions. That means I combined the terms. What I mean by that, what we did in 9.4.9.5, I'm going to look at the numbers and I'm going to look at the signs. So if I do 4 minus 8, signs are different. I subtract, keep the sign of the larger. Now it tells me to keep variable, keep exponent. Keep my variable, which is a c. And there is, again, y'all, a little invisible 1 right there, okay? So do you see what I'm saying? You look at the actual coefficients, the numbers, the numerical value that you have. Combine those, right? Paying attention to the signs, of course, and then keep and keep. When you add and subtract variables, you keep and keep, okay? That's why they have to be the exact same. So problem 2, 2x plus 5x. Same variable? Yes. Same exponent? Yes. Okay, I'm going to combine my terms. 2 plus 5. Signs are the same. Add and keep the sign, and then keep and keep the variable and the exponent. Okay, so problem 3, we've got 4 terms. I can either rewrite this with all of the like terms together, or I've usually been partial to just kind of maybe putting a squiggly line under things that match, or boxing it or circling it. Be careful with boxing and circling, just because you could accidentally draw a line through a negative sign and now it looks positive, and your combination of your terms could end up being incorrect. So be really careful with that. I'm going to actually just underline the 2 terms that I notice are the same. That 3x and that 5x, those have same variable, same exponent. You notice I didn't just use a line. I used kind of like a bracket. And what I did was I made sure to put that sign with that 5, right? Because that's saying that 5 is positive. If there's a negative sign there, that negative goes with that 5. And that's how it's going to help you to combine your terms. So if I look, I've got 2 terms that have the same variable, same exponent. Now let's look at the actual numbers. That's a positive 3, positive 5. Signs are the same. You add and keep the sign, and then because there's variables, I keep and keep. Now for my other terms, I didn't show an example of this up here, but excuse me, if you just have numbers, coefficients, just values that have no variables at all whatsoever, those are all like. So the number 8 and the number 6 are alike in the fact that they may be representing different numerical values, but they don't have a variable and neither of them have an exponent. Well, you can only have an exponent if you have a variable, right? But neither of them have a variable. So since neither of them even have a variable, they are alike in that sense and they can be combined. So if you look at 8 and you look at 6, their signs are the same. So what you would do is you add, I love it when it does that, is you add and you keep. Now look at it again. My 8x and my 14, are they alike? No, my 8 has a variable, my 14 doesn't. So this would be that highlighted answer, no. Same variable, same exponent, no. Now my step says cannot combine. What I mean by cannot combine is they just are what they are. You can't perform any math right here. The answer is both of those terms, 8x and a positive 14. Okay, so let's get over to problem 4. Okay, so I did this one just because I was hoping that you would actually recall what we did in the previous section. If you look, let's go ahead and ask myself my questions. Same variable, same exponent. Well, I do notice that this positive 2b and this positive 4b have the same variable and the same exponent. So I can actually perform my math there, right? Now let me look at my other terms. I noticed that this 36 has a b squared and that negative 36 has a b squared. That's why you have to make sure those signs, y'all, go with the number that it's right in front of. Okay, if you're not careful, you'll just see 36 and 36 and think, oh, wow, what does that even equal? 60, 72? Oh, I've got 72 b squareds, right? No, that's not true because of this negative sign right here. This one doesn't have a sign, so we're implying, right, that it's positive. What did we learn about additive inverses? Additive inverses said if you have the same number and the different sign, they cancel, right? It goes to zero. And the reason why I can do that on these two terms is because they have the same variable and the same exponent. So literally, y'all, excuse me, those went away. Make sure you pay attention to your signs. Problems like these, one little sign error, the whole answer is wrong. Like you could have put a ton of work into it, a ton of thought behind it, but if you mess up one sign, you now have a completely wrong answer. So let's look at what's remaining. I have a 2b and a 4b. Those are both positive, which means you add and you keep the sign, right? That positive sign. And because I'm combining variables, you keep the variable, keep the exponent. 6b is the final answer to that problem, not 6b plus 72b squared. Okay, do you see how those are completely different? Okay, so I did this one right here because in the homework, I believe they're honestly just trying to confuse you. Everything I've told you thus far has been pay attention to parentheses, solve what's inside of the parentheses, and then continue on with your problem, right? Well, if you notice here inside of those parentheses, what I have is a 6 and a negative 4p. Question, same variable, same exponent? Answer, no. Result, cannot be combined. That does not turn into a 2p. Please do not turn that into a 2p. My 4 has a variable p. My 6 does not even have a variable. Those are very different terms. So maybe just to kind of clear up a little confusion, what I would like to do, I evaluated that parenthesis and I came to the determination? No, I came to the conclusion that I can't do anything inside of that set of parentheses. So I'm just going to rewrite the problem so having them doesn't confuse me, okay? Now, I rewrote the problem right here, y'all. If we solve this, let me look. I have a positive 1, I have a positive 6, and I have a negative 2. Now, those don't have a variable, so what I can do is actually combine them. Following the order of operations, I need to work from left to right, so I would combine the 1 and the 6. Signs are the same, so you add and keep. Continuing to write my problem, because I haven't done anything with that negative 4p, I would write that right here, and then I have my negative 2. Well, I still see that what I have here is a 7 and a negative 2. Those are just regular coefficients. Those are just regular values. They can be combined. And if I do combine them, it's okay to combine them in front of your 4p. You could even put it after your 4p. I'm not sure if the homework would accept it both ways, but I will show you both answers. So if I look at just my coefficients, those signs are different. So I would subtract. I'm going to do it in blue. Those signs are different, so I would subtract, keep the sign of the larger, and then I have my negative 4p. Okay, so that is the answer because those are not like terms. Another answer would also be to write it as negative 4p plus 5. And I know that I can do this because I learned the commutative rule, which states that the order of things can be changed. Now, if you do notice, I think this answer may be more correct because usually what they want you to do is write your variables in descending order, which means they would want them to be written with the highest exponent down. And so like after this would be just any coefficient, right? So writing it this way, I have it in that order, but whoop, that's really ugly. This is the exact same answer. They are both equivalent to each other. Okay. If y'all have any questions, let me know. Thanks, y'all. Bye.